Let's talk about limits. In our previous video, we talked about limits graphically. What we saw was that if we have some graph f of x, we can visually determine the value of the limit pretty easily. Here we see that the limit of f of x as x approaches 2 would come out to be 3 because as we get closer and closer to this region right here, our heights get closer and closer to the height of 3. Now, while finding limits graphically is relatively straightforward, we're not always given the graph, or we might not be able to sketch the graph with ease. Instead, we might make a table of values to investigate what happens to the behavior of the function as x approaches that number that we're interested in. Here we're given a function of f of x, which personally I don't feel very confident in sketching this. So instead what I've done is I've gone ahead and created a table where the x values get closer and closer to x equals 1. So what do we notice? Well, as I approach x equals 1 from the left side, so my numbers are getting larger and larger towards 1, I notice that the y values seem to get closer and closer to a value of negative pi. Remember, pi is about 3.14 approximated. Similarly, we see from the right side, as x gets closer and closer to 1, our y value seems to also get closer and closer to a value of negative pi. Therefore, the limit of our original function as x approaches 1 is equal to negative pi. Let's go ahead and take a look at a problem to illustrate our point. Here we're given a table of values for three functions, f of x, g of x, and h of x, as x values get closer and closer to 0. We'll start by finding the limit of f of x as x approaches 0. What we notice is looking at the f of x row, as my function gets closer and closer to an x value of 0, the y value gets closer and closer to 7. Note that the function's value itself is at 20, but the value of the function is not approaching 20 here, it's approaching 7. Therefore, we'd say the limit of f of x as x approaches 0 would equal 7. Now, let's go ahead and find the limit of g of x as x approaches 0. We'll do the same thing, look at the row for g of x, and we look at what happens as the x value gets closer and closer to 0. What we see is that from both sides, the function seems to be approaching 8, and we also see that the y value there is 8 as well. Therefore, the limit of g of x as x approaches 0 would be equal to 8. Last but not least, we'll go ahead and find the limit of h of x as x approaches 0. We look at the row for h of x, and what we see is that as we get closer and closer to a value of x equals 0 from both sides, the y value seems to be approaching a value of negative 1. Note that the function itself is undefined at x equals 0, but the limit and the function are not the same thing. The limit tells us what y value we approach and not necessarily the y value that really exists at that point. Therefore, we can say that the limit of h of x as x approaches 0 is equal to negative 1. There you have it. That's how we would go ahead and solve a limit tabularly. Note that whether we were finding a limit tabularly or graphically, we always looked from both sides of the point. What that means is we always looked at what happens as I approach from the left side and what happens as I approach from the right side. This leads us into the idea of one-side limits, which we'll look at in our next video.